As always, I'd like to get started by asking if you could please introduce yourself and your group and tell us about your background.
Sure, I'd be happy to. My name is Michael Dickey, and I'm a professor of chemical and biomolecular engineering at NC State University in Raleigh, North Carolina. And although my training is in polymeric materials and nanofabrication, my group has been studying liquid metals for about a decade now. These materials are interesting because they are both liquids and metals. Most people think of mercury when they hear the term liquid metal, which is a bit unfortunate because mercury is known to be toxic. Instead, our group and others have been studying liquid metal alloys of gallium, which are considered to have low toxicity relative to mercury. And importantly, these metals form surface oxides that act like a thin shell. And this oxide shell allows the metal to be patterned and manipulated into shapes that would not be possible with conventional liquids like water. We've been studying these materials and taking advantage of their properties to make soft and stretchable electronics in our group.
So, in your recent study published in Extreme Mechanics Letters, you reported on a new method to create flexible wires using polymers surrounded by liquid metal. Before we get into the technical details of how, can you tell us about the need for flexible electronics?
Sure, I'd be happy to. There's a lot of interest right now in making electronics that are flexible and, in some extreme cases, stretchable or even soft. There are at least two reasons I can think of for this interest. The first is just simply to give electronics greater functionality. A simple example of that would be a phone that could be folded, for example. The second is to put electronics in places where it is currently difficult. So an example of that might be some electronics on or inside the body, maybe within or on clothing, or in other things that we come across in our daily lives. If you sort of take a step back and think about it, our bodies and many of the things that we interact with in our daily lives are soft and deformable. And in contrast to that, most electronics are made from rigid materials. So ultimately, there's a mechanical mismatch between the electronics that we have and sort of our bodies and the things that we experience day to day. So our group and a number of other groups around the world have been looking at ways to make the electronics with interesting mechanical properties. And, we've tossed around a couple words here, flexible, stretchable, and also soft. And if you think about flexible, it's possible to make electronics flexible by simply making the components thin. And there's plenty of examples of this in our day-to-day lives. So, for example, aluminum foil is flexible because it is thin, even though bulk aluminum is a very rigid material. In fact, you can make bicycle frames out of aluminum. And we've been really trying to go a step beyond flexible electronics to try to make conductors that are stretchable and also